Live streaming is on.
Hello, and welcome to the next Nix Hour. Today we have a question here in the meeting. Otherwise, we'd go through the Nix Hour repository as always. And we might look at this later. But yeah, Dan, you had a question. Feel free to share it.
Sure. So Yuri and I were pairing yesterday on some Nix code, and we were curious about how callPackage, newScope, and there's another important one. I'm trying to remember what it was.
makeScope, maybe.
makeScope and makeScope, how they kind of all interact, like how you're supposed to think about them, and
Yeah.
maybe examples of that.
Yeah, that's a good question. Can you see my screen?
Yes.
Yes.
All right, nice. So yeah, let's go through that. And so I believe, right, the main one is make derivation. Let's maybe rewrite a small sample here. So I guess let's say you were writing your own small package set, and you might start with this. Wait, with this. I hope the keyboard sound isn't too annoying.
No, that's fine.
Okay, so you might start with something like this, where you use callPackage and have like a foo.nix package in here. Now let's foo.nix. This is a bit wrong. Need to pass an argument. So and then foo.nix, you'd have the usual like. Let's just put a run command in here. Run command test, and then let's just echo test2 out. Very simple derivation. All right, now we have sample.nix, and you can build this with nix build-a foo. Oh, we need to pass sample.nix. All right, that works. But now let's say you had another package in here. Let's make this a bar. Let's for now just copy foo.nix to bar.nix. And in here, let's call this bar. All right. And now we can build foo, and we can build a bar. That's great. But now let's say your bar depends on foo. So let's go into bar. And how do we want to do this? Because if we just try to access foo in here, that will not work. So let's say we do cat foo to out. So we just copy, well, it's prepend bar here. Sure, this is fine. So we want to copy the result from foo into bar. And if we try this, it won't work because we don't have a foo. And so an easy way to solve this is using this. You can go in here and you can pass foo directly here. But now, what would it be here? Well, we could use a rec here. Rec is a sometimes discouraged though. Another way to do it would be to say, oh, let's declare foo at the beginning here. So we do this, and then we can inherit foo here to propagate it, so we can still build foo directly. But we can then also do it like this here. We can inherit foo here as well. Inherit foo. All right, and this works. So now we can build bar, and we can also cat the result. Oh, that's not right. Cat the result, and we get test back, and test is what we wrote in foo. All right, but this is a bit it's a bit weird. When we have more dependencies, we would have to like copy everything up here, and a let binding is pretty much just a rec binding, but I guess there's not exactly the same. And so a different way to do this is to create a scope entirely in here. So we might do this using just a fixed point function. So this would maybe look like this. Let's write fixed point. And we have a self here. Well, self, let's just call, or let's use final and define it like this. So we do foo also in here. So we have our foo and bar in here. And then what we can do is, instead of inherit foo here, we say foo equals final.foo. And then this is just a function at this point, but it's kind of recursive in nature. So final should be the final attribute. We can now call this and make it a real thing using lib. Let's import lib here. Lib equals packages.lib. Lib.fix. That's one of the kind of easiest ways to get a fixed point. And so now this should work. So lib.fix, what it really does is it's the same as this. It does let x equals fixed point. Well, this isn't the fixed point. Like, let's call it f. So it creates x, and it applies x to f itself to get x. And so this works because Nix is lazy in nature. And so this won't give like an infinite recursion here. And let's try this. So still build bar, and we can get the result. So this works, and this is the same as lib.fix for f. All right. But now, what if someone were to want to extend this set? So let's say we have our set here equals lib.fixf. Now, well, we can export the set directly, but now we want to be able to override these paths, these attributes in here. And there's no real way to do this because this is now an attribute set, and it like got rid of the original function. And so if you want to do this, there is lib.makeExtensible. So makeExtensible is pretty much like lib.fix, but you can extend the fixed point with more attributes. And so in here, what we can do, well, let's first try it out. That still works. And we can also look at the result here a bit more closely. So let's go into the Nix REPL, sample.nix. Well, let's not do it like this. Let's do s equals import sample. And now let's look at this, and we can see some other things here. So we have foo here, we have bar, these are derivations, but we also have this extend function. And this is what allows us to extend the set of attributes. There is also unfix here. This allows us to get direct access to the underlying recursive function, but it's underscored here, so it's not entirely meant as a public interface. Yeah. And so what we can do using the extend function is we can give an overlay in here. And so we can say pref final. Let's say we also have a baz equals to, let's say, 10. All right. Once we do this, the result here includes baz. And so this is more powerful than just a normal like // because we could also just do this // baz equals 10. That also works. But if we use the extend here, we can access this baz definition inside of the foo baz as well, foo bar definitions as well. So I can go into bar here, for example, and say, oh, we want a baz, and let's extend this a bit. Let's convert this to multi-line string, and so we cat that, and then we also do echo, or let's do this in the beginning, echo toString baz into out, then let's make sure to not override it here. All right, and let's also make a default value here, because by default we don't provide one. So let's try this, so we can still build bar, and that works, and it contains our 0 here. But now if let's go back to Nix REPL, and let's import it, and now let's do this extend here. And let's say as prime is this extended version. Now let's build as prime dot bar. Yes. So produce the following outputs. Let's cat the result here. Oh, that's actually still the old one. That's a bit surprising to me. Swifu. I think we changed this. Bar.
I think it would work if you were to override the value but not create new value for bars, because callPackage works with the set with the scope that you have, right?
Oh yeah, that's true. Yeah. So, but in the sample.nix here, we are not right. CallPackage uses the package set, and the extra arguments we pass here, it doesn't by default pass all of final. So let's make it work manual here. Let's pass bas equals final.bas. And we can also do an inherit final foo bas for a bit more simplicity. All right, now it should work. So let's do the Nix REPL again. Import, extend, and build the bar. And the store path changed. So yes, we have the 10 now. So yeah, this allows you to pass extra arguments from, like, right, you can extend it later.
But
now
it will not build, right?
It should still build.
Without extension.
Oh yeah, that's, I think so, yeah. Yes. Right, bas is missing by default here, so we'd have to do it here instead. So bas equals 0. Right, and then it's going to bar and remove this default, which isn't used now. All right. Let's build it, and that then works again. But now now let's go into the, so this is a bit annoying here because we need to always pass all the inputs we want from this set. And so this is where the kind of makeScope and newScope come into play. Now I will have to look at an example in Nixpkgs, how to do that exactly. Okay, I think I know how. So I believe it should work like this: makeScope, then we pass pkgs.callPackage, and then we pass the function here. This isn't necessary anymore.
Is it newScope instead of callPackage?
So that's kind of the thing. newScope is callPackage, as I'm fairly sure. Let's try it like this. And let's look into that a bit further afterwards. So well, now this, as far as I know, shouldn't be necessary anymore. Function call without bas. Yeah, that's not entirely right. Okay, let's try newScope then.
You use packages.callPackage, not, you should use final.callPackage, I think, here.
Well, we can't. So makeScope, as far as I know, it takes like a callPackage-like function and extends it using an extra set. And so this, I mean, we don't have final here yet. Final is only accessible in here. Oh,
You cannot
here.
change callPackage, right?
Yeah.
Yeah.
You're right. So final should be used here. Good point. Let's try this. Not exactly. I believe. can of course a set to a string. So this is inside callPackage. So it tries to import the something here. Is it? That's a bit weird. All right, let's look at an example. Do we need newScope? Let's try that. Oh yes, that works. Thank you. All right, newScope it is then. Yeah, and so now we should be able to remove all of this. And yeah, so anytime you use final callPackage now inside here, you have access to both this set of arguments here and the set of packages from Nixpkgs. Yeah, so it's kind of gets merged together. This can cause problems because now you have a merging of namespaces. So when you have, there's a package called source, actually. That's a bit of a weird package, but I believe it does exist. So when you have that, of course, it's going to override the source package in Nixpkgs with your own definition. Let's try this. Source, does it exist? If it wouldn't exist, it should complain. Yep, indeed it does exist. Yeah, so that's just something to watch out for. What you can do to avoid this, I haven't seen this a whole bunch, but it's an idea that I just had, was to make my package set equals this. Well, I guess then you have the problem again. You might have to, well, I guess it should be fine. But yeah, kind of create your own package set here, and then in bar, you'd, instead of taking these arguments directly, you could say my package set here. Then my package set dot baz and my package set dot foo. Oh yeah, bar not found, I believe. Do we have? No.
It's an argument to Nix build to pass bar instead of my package set dot bar.
Oh yes, thank you. Yes, my package set dot bar. I guess we could also, honestly, I feel like I shouldn't recommend doing this, because now if you were to, for example, only return this package set, you can't override it anymore, because the overriding is still possible, but on this f here. Well, this isn't a function anymore, it's the set itself. So let's go back to this old way of doing this. This is more common both in Nixpkgs, and I don't think many third-party packages use this approach, but it could be used. All right. Oh, I'm on a different keyboard today, so I'm not as fluent. Yeah, so like this.
Will passing default for bars work now?
Let's see, I think so, yeah. So yeah, we could get rid of this, go in here, pass it here. This is also how Nixpkgs often does it, to set default arguments. Let's try it out. Yeah, that works. And maybe just something related. Well, usually if you have a, this would be a default.nix. Usually I'm just in a repository here, so it can't be default.nix. But you would have a function here often to make it more convenient for passing in arguments if you need them. And we could also do this here, set the default here, inherit baz. Let's get rid of it here again. And then we could set the argument here. So arg baz 10 cat result. Yep. All right. So let's maybe, let's look at this. So the kind of good thing about makeScope and newScope is that you can nest it. So we can even have this, like my nested package set, kind of like we did before. Or let's say just pkg set. So I believe we should be able to do this. makeScope, probably final.newScope. I don't think the documentation on this is very good, so that's why I'm just kind of guessing here. And let's have pkgs here and make this a final.callPackage too. Let's, for a bit less confusion, let's name this final prime. Final prime.callPackage, and we're going to say xqx.nix. And now, well, let's do. Oh, we don't have the file yet. Let's say let's do something interesting here. Let's take the package itself as an argument, and then let's do a run command, and let's do sure like this. Let's pass. No, we can't really pass this in. Oh, we can do a pass through dot. Let's say like next level, and for that, oh, actually that. Yeah, what if we try something like this? Level starts off with 0. Actually, this might get really messy. Let's not do that. But you can refer to itself here, and then let's maybe just do like an override atures old level equals 2, and here by default we say level equals 1. Then for building we say echo level to out. All right, now we should be able to, if that all works as intended, package set dot pkgs and cat result. Oh, undefined variable run command. Right, we need to get this as an argument. And that works. So we have 1 here, but now we can also do this because we have the pass through. Oh, it's next level. Yeah. Yeah, so in here you now have access to both, well, the Nixpkgs scope, you have access to your own scope, and you can also get foo as well here. So we could do echo or cat foo to out as well. All right. Yeah, so that's kind of nice on these makeScope and newScope. Something else that works is, I believe it properly handles cross-compilation. So if, let's go maybe to bar again. It's a bit harder to demonstrate that, but let's say we had a build inputs, and we had, let's say, OpenSSL in here, OpenSSL, and we also have a native build inputs. So native build inputs is tools you need during building. Build inputs is tools that will end up in the result. So those are needed for running. And so in here, we're passing the very same argument to both functions. But if you use cross-compilation, these will have to be different because you build on one system. Let's probably move this up here. Because you build on one system, but run on another system. So these need to be different. And in Nixpkgs, that works because these arguments are spliced, which I believe means that they have a some special attributes that native build inputs and build inputs knows about, and it's going to use those attributes when they exist. Let's maybe to check that out. Let's do like a built-ins.trace, and lib.attrib or buildhints.attrib_names OpenSSL. So let's build bar. We don't even need to build it. We can instantiate. Sure, we can build it. So we can see these arguments here. I believe. Oh, I don't actually see it immediately. Yeah, there's no kind of splicing thing in here. It might be more hidden than that, actually. Let's check Nixpkgs for this. So customization, that's where all of these, or most of these, should be defined. Let's go to newScope or makeScope. Oh, and there it is. Some docs in here. So callPackage, overrideScope. Oh yeah, overrideScope. We haven't touched that. That is important. Oh, okay. Yeah, this is it. I think this one is actually fairly new. So makeScopeWithSplicing. It's a bit more annoying to call it, though. We have a lot more arguments. And in my opinion, so as soon as you have a bunch of these arguments, and it could get confusing which one is which, I'd recommend doing an attribute set here instead of a curried function call. So this is how I would do it. This way people need to name the arguments correctly. But yeah, so I guess if you need splicing, if you need cross-compilation to work directly, look into this function. There should also be examples of this in Nixpkgs. So if we grab for this, we have, oh, this is in lib. Yes, we have Python as an example. makeScopeWithSplicing. Okay, so this is apparently how you need to call it. Don't really want to look too much into that right now. That's a bit complicated, but if you, as long as you have examples, it should you should be able to make use of it. Yeah, but I wanted to talk about overrideScope. So we did this package set here, but we haven't yet done the extend from before. So before we could do extend to add this prev final, this overlay, this additional one on top of the package set. This doesn't exist as extend here. So if we try this, it's going to say extend is missing. Instead, the way to do this here is to use overrideScope. And so, a bit of a historical background here. You need to use the prime version because traditionally you had an overrideScope without a prime, but it had the arguments flipped. So final was first, and prev was second. And this is not great. And now instead of just changing the order, because that would just break all the code, it was decided to make it a prime version instead and deprecate the old function. And the prime one now has the right order, but it has a prime, so it's that's a bit weird. But
So
yeah, and here
what do you
we
mean
can.
by the right order, because final previous was always the right order that I've seen in terms of overlays and overrides.
Oh, did I? Yeah, actually, I might have confused the order myself here. Final prev. Is it final prev? I think so.
Can you double check one of us or back one of us up, because I thought it was final prev.
I also think it's final first.
Okay, so let's use final prev and hopefully see, well, if it's wrong, we can hopefully see an error, but I should really know this. I've been writing overlays for like years now. So let's try to override this here. So well, we have a default that's passed from up here. Actually, yeah, we could, that might be interesting. So let's remove, well, let's keep this here. Let's go into bar again. And let's add, no, let's leave it like this. So bar, add baz, blah, blah, blah. Let's just override it here. So baz equals, well, I don't know, 10, sure. Let's build it and cat result. And yeah, you can see 10 was applied. Yeah, so that's just override scope. I also, let's see what happens. Oh, actually, we should get an error message or a warning if we use override scope without a prime. Yes, here. Override scope is deprecated. Do override scope prime. Oh, self super. Yes, so final pref is the right ordering. All other overrides have the parameters in that order, including other definitions of override scope. This was the only definition violating the pattern. All right. So I think that pretty much covers the whole makeScope thing. Maybe we can look a little bit more at the definition makeScope here. See if we have anything more interesting here. So we have newScope. We saw that. We used that to create a new nested scope. You can pass this to a nested call of makeScope itself. It's also the argument name here. We saw callPackage. That's how you call packages, make it pass all the arguments. We have override scope that comes with a warning message. We have override scope prime. That's the new version for adding a new overlay. And we have packages itself. Oh, that's the fixed point function. All right, so we could get back the function itself. Let's try this here as well. Let's go into Nix REPL. Let's import sample s dot autocompletion doesn't work. Oh, right, it's a function. We have this argument. Right. So packages, we could also get that. I'm not, so it's lambda. I'm not entirely sure what the use case for this is. Let's just flip the order around here again. Oh yeah, final pref, that's right. But yeah, I guess if you need it, you can get this one too. Yeah, I think. Do we have any other questions about the makeScope, or was something unclear here, or should we look at something else around that?
I have a question. Like, does it make sense to start a new scope? Like, for example, if I don't want packages to be in my scope, but like, does it make sense to start a new one? And is it the correct pattern for, like, for example, I have a library of a bunch of packages or functions and stuff. Does it make sense to use this for that?
That's an interesting question. I would say no, because you don't. Well, yes, if you don't want to end up. Well, actually, look, we have. I mean, this is kind of what you want, right? So we only have our own packages in this final package set here. Is this what you mean?
No, but here you still have package set that has. Oh no, wait. No, it's more like what if I don't like? I want to separate functions into separate files, right? Essentially, functions or packages into separate files, like, and use it with callPackage, so that I can list all the dependencies in just function arguments. But I don't want to string packages themselves there, like the scope of packages there, so that if you want to depend on a specific package, you couldn't do that, or you could just, I could pass packages argument there instead.
Oh, is it so? It's like instead of getting dependencies like this, to instead just have packages here.
Yeah.
Get it like this.
Does it make sense?
I guess that could be done. Yeah, let's try it out here. So, well, one disadvantage you might have is that the splicing won't work like this. I believe the splicing somehow interacts with the arguments here for it to work correctly. But yeah, we'd also have to use the new makeScopeWithSplicing function we've seen earlier for that to work. But yeah, this can also work. For that, we'd probably do. I wouldn't use makeScope, I think. Let's do alternate set. And yeah, honestly, for this, I believe the makeExtensible is the better approach. So we have this, and we just set inherit packages. And then we will define foo and bar in here. And let's just make sure this works.
But we don't have a call package here, do we?
Oh yeah, that's true. We need also a call package. So, so we can use we can define this manually at least. So it's lib.callPackage with. So call package is defined based on this with the additional argument of packages. That's how it's defined in Nixpkgs. But if we don't want the entire package set there, we can just use final here. So this will only have these arguments here. And yeah, this should pretty much work then. Let's try it out. Alternate set. Next build -a bar. Function called without pass. Fair enough. We didn't pass that. Let's just add the default 0 case here again. Run command. Yes, where was that? In foo, I guess. Yeah, so we'd have to change this one as well. Packages.run command. And that works again. Yeah, so I think either of those is fine. I'd probably recommend this version over this one because you won't run into namespace conflicts if you use this one. I would like to know, though, if there's a way to... It is a bit weird because now you have the extend function, which needs to be used instead of the overrideScope. But they do have the same functionality. Yeah.
We actually, by trial and error, we found that we could, in theory, use like makeScope, but instead of passing packages newScope, pass the like lib.callPackage with directly instead of newScope, because like newScope is defined weirdly.
That's a good point. Let's look at how newScope is defined. I believe for for Nixpkgs, I believe it's somewhere in maybe here. newScope, no, it should be the top level.
It's not named argument.
It's here. Scope. So yeah, it's actually pretty much defined how. Yeah, it also uses call package with. So actually, yeah, we can. Oh, my terminal just crashed for some reason. So yeah, we should be able to do this as well. So let's go into here. So this is the newScope definition from Nixpkgs. Let's try to copy this. So let's use this alternate set prime. Sure. And so we use the, let's remove this. So we want to still have inherit packages, but we use makeScope now. And our own newScope is going to be like this, a call package with. and we're gonna pass the empty set here. Yeah, so by default, we do not have any packages in the scope, and it gets extended with these attributes here. So maybe we can even inline this here. Like we are not even using this parameter. Let's call it appropriately.
I think you still need to add extra.
I'm passing an underscore here, which could still be used as a oh, extra, yes. You're right. You're very much right. It is used, yeah. So this is how it actually gets extended. Otherwise, we'll never be able to extend the set here. And this, we can eta reduce this to just this, actually. So that's fairly simple, actually. And let's use the prime version here. And it works. Very nice. So yeah, this looks actually pretty good. Override it, yes. Let's try that. So we can just remove this. Let's do. Sure, we aren't using Baz here anymore. Oh, actually, no, that should work. Yes. So let's try this. Build it. Yeah, 10 gets applied. All right, so that works actually pretty well. So yeah, that would probably be my recommendation. Well, honestly, I can't give like a super clear recommendation. I think any of these pretty much do the same thing. They just have either .overrideScope or .extend. So .extend is makeExtensible. And well, this has the advantage that you can get splicing to work easily, and it is a bit more standard too. It's easier to upstream these. So if you were to upstream bar, you could just upstream this file pretty much. Oh, actually, we changed it here. It would look like this. Yes. All right. Do we have any other questions about this?
Could you explain again, like, what that last alternate set prime did compare to the original set?
So this one compared to, well, we should have named these a bit better. But yeah, the difference here is that in alternate set, you do not have all the Nix packages in scope. So in here, bar, this won't work. We aren't able to do this run command and OpenSSL. We started out with this, so this works with the set definition. So we can do. Oh, actually, why does this work right now?
You didn't save that file, I think.
Oh, now that might be true. Yes. Oh yeah. So now we're evaluating the alternate set here with the arguments like run command and OpenSSL, and it says that we cannot do that. OpenSSL isn't in scope, and so here the scope is only these three arguments here. So we only have packages, foo, and bar. If we need any arguments from under packages, we need to do packages and then packages.run command. Whereas with the above here, because we used the packages.newScope here, we have all the Nix packages in scope. So here we can do run command and run command directly. Does that make sense?
Yep, I think so.
All right.
Thanks.
Yeah. So any more questions?
I remember there was also a question yesterday about where actually self comes from. I don't know, is it possible to answer this without diving into functional programming theory?
I think so. Where like the final, or I guess
For
maybe a
example, in
bit
fixed
how
point, where
overlays.
does X come from?
Oh, like this down here, how that even works. Yeah, we could. I mean, it's very much related to what we're discussing right now. Let's maybe have let's do like fixed points, but let's just try a little bit here. We can do this very manually even. So let's say we have a function that's self-recursive. So let's call this f, and we start out with a self in here already. So we just assume it points to the own result. Let's say we have an a equals 0. Well, no, let's say a equals 2, b equals 3, and then c equals self.a plus self.b. And yes, so now we used the lib.fix earlier already, but let's define it ourselves here. So fix equals let x equals, well, we need to take a function f, and then this, and then this. Now fix f. Well, this is a bit confusing. Let's call this g. All right, and now we can do, let's do nix instantiate eval
Line 9.
fix.next. What 9?
X equals g of x.
Oh,
It should be-
yeah, I undid this x. Yes. All right, so this works. We have a, we have b, and we have c equal to 5. And so how, I mean, we can, let's dig a little bit into this. Let's also indent this a bit better. So how this works, I mean, let's do like a substitution. So we dig into it. How kind of the next evaluation, how you can simulate it, is you copy the definition of the function you're evaluating here, and you replace it. So we go in here, we do this, we put the function here. Let's also wrap it properly. Yeah, like this. So like this. And now we need to insert this argument into this function. So we substitute g in here with f. So let's put f here. Let's remove the argument. And remove this. All right, so well, we end up pretty much at the same thing. Now we need to, well, actually this kind of gets, I'm not sure, I don't think I can actually explain it like this here. So how it actually works is that when a let binding is created, a thunk is created here. And the thunk pointing to a thunk consists of an expression and an environment. And so thunk stores these two pieces of information so that when it needs to be evaluated, it can be done by evaluating the expression in this environment. And so this is how it goes into here. So it evaluates the thunk kind of right away. But it also, because it's recursive, it passes the thunk of x into this function directly. Or the variable, the thunk, it's kind of pointing at the same thing all the time. Yeah, and so, well, I guess we can. This is really hard to explain just on the fly. Let's maybe do some other substitution here to see what might happen. So we insert the actual function for this. Now here we could do, oh yeah, we can do the substitution again. So, or the insertion of the argument. So we can do this. We can say instead of self, it's now x. That's what it points to. And now, I mean, we can do this again. So we have x, we have a, and we have b. Now, attribute sets also creates a thunk. So in the end, these point to the same values, which means we can insert this here as well. So 2 plus 3. We can then, probably won't get evaluated yet, but we could then insert this at the end here. Sure. And then that's pretty much the result. And if we evaluate C, it's going to turn this plus into that. Something like that. It's not as pretty, but generally, to kind of evaluate Nix, you can just do a bunch of substitute or inline variables, and you can apply function arguments, like a lambda plus apply cancels out. Kind of like that. Yes.
None of this happens until you actually run evaluate or like instantiate or whatever.
Yes.
Right? So
yes.
essentially, we after you just parse or like import this file from a different file, you get just the thunk, right? And only if you try to access C, it will get this recursive evaluation, right?
Exactly, yeah. It does exactly only what is necessary.
Okay.
Yeah, and I mean, so here it will be necessary, for example, so it sees, oh, we have an X, but it's not evaluated yet. So at the start, it will point to a thunk. It will be unevaluated at first. And then it's gonna do the evaluation until it gets to a value that it can access an attribute of, which will be an attribute set. Yeah, well, I briefly also want to go. Yeah, let's briefly touch. We have like a couple more minutes. Let's touch on fixed points as well. Well, extending fixed points. So let's do the. Let's remove this again. So we have lib.fix, so we can fix f. That works. And then we also have the makeExtensible. Let's do. Yeah, let's use lib.makeExtensible. It's a bit harder to define that one, so let's not do it ourselves here. Actually, sure, let's try it. Extensible. So we have this here. So this is the extensible version. We can do extensible.extend. We can say self. Or this is, let's use final pref, and let's say a equals 0 now. Let's try this. We evaluate C, and there's a syntax error because I didn't close the parentheses. So C is only 3 now. It's the same as B now because 3 plus 0 is 3. But now let's try something interesting. Let's use combined fixed point function. Use lib.composeExtensions. So what composeExtensions does, it's going to be a little bit weird here, but it takes 2 overlays and it composes them into a single one. So, well, to fully simulate this, let's extend again afterwards here. So let's extend a second time, and let's set b to 2. So now if we evaluate C, it's going to be 2, but we can combine these 2 overlays into a single one using composeExtensions. So we can try final pref. The first one is going to be a equals 0, and the second one, final pref, is going to be b equals 2. And now we only need to pass this single one. So I'm going to delete this. Only going to extend this one with this combined fixed point function. All right, and that works. So you will probably see this more often with actual Nixpkgs overlays, like the top level overlays you can pass to the Nixpkgs fixed point. But yeah, this is a generic function to compose multiple overlays into a single one. So the result of here is also type. It takes like, it's kind of like final prev, and then address set. Yeah, so if you want to be more functional, overlays are a semigroup, or actually a monoid as well. Semigroup can be combined, and monoids have an empty element, which would be final prev, the empty set here. And the empty element doesn't change the result. So you can like use composeExtensions with an empty overlay, and it won't change the other overlay. Anyways, yeah, we are out of time. I am only on one screen today, so I couldn't see any messages. But I hope this was useful, and see you next time.